To get started, go ahead and multiply these two binomials, 3x minus 2 and x plus 4. Be sure to combine all the like terms in your answer, or click down here to review. Nicely done! One way to expand this product is with FOIL. The first terms, 3x and x, multiply to 3x squared. The product of the outside terms is 12x, the inside terms is negative 2x, and the last terms is negative 8. 12x minus 2x is 10x. So 3x minus 2 times x plus 4 equals 3x squared plus 10x minus 8. Next, let's look at another way to multiply binomials. Let's draw a table, and let's give each term in the first binomial a row in this table, so that's 3x and negative 2. And each term of the second binomial gets a column, so that's x and 4. Now for each box in our table, let's multiply the row and the column. So over here we have 3x times x, or 3x squared, and over here we have 3x times 4, or 12x. Down here, negative 2 times x is negative 2x, and over here, negative 2 times 4 is negative 8. If you add up these four boxes, you again get the product, 3x squared plus 10x minus 8. And that's no surprise. 3x and x are the first terms. 3x and 4 are the outside terms. Negative 2 and x are the inside terms, and negative 2 and 4 are the last terms. So using this table is actually the same thing as the FOIL method. So try another example. Use a table to expand this product. 2x minus 1 times x minus 3. Remember to combine like terms, and if you get stuck, feel free to ask for a hint. Exactly, so the terms of the first binomial are 2x and negative 1, and the terms of the second binomial are x and negative 3. Here are the four products you get, and these two are like terms. So this product is 2x squared minus 7x plus 3. So why would you ever use this table method instead of FOIL? Well, FOIL only works with binomials, but the table method works for multiplying any two polynomials. Suppose you're multiplying the binomial 3x plus 1 by the trinomial x squared minus 2x plus 5. This is a trinomial because it's a polynomial with exactly 3 terms. So how can we expand this product? Well, let's add a third column to our table. Again, each term of the first polynomial gets a row, and each term of the second polynomial gets a column. So what's the product of these two polynomials? Again, be sure to combine like terms, and feel free to ask for a hint. Nicely done. So here are the 6 terms, and if you add them all up, you get 3x cubed, and then you have 2x squared terms, which add up to negative 5x squared. Then you have 2x terms, which add up to 13x, and finally you have plus 5. So this product equals 3x cubed minus 5x squared plus 13x plus 5. As you can see, multiplying polynomials like this can be a lot of work. So let's just get through a few more examples and call it a day. With the table method, you can multiply polynomials of any size. If you're multiplying trinomials like x squared minus x plus 2 and x squared plus x minus 2, then you'll want 3 rows and 3 columns. So try expanding this product. Excellent work! Here are the rows and here are the columns, and you found 9 terms in this table. So this product is x to the 4th, then the x cubed terms cancel out, adding up all the x squared terms gives you negative x squared, adding up all the x terms gives you 4x, and the final term is negative 4. So this expansion is x to the 4th minus x squared plus 4x minus 4. Okay, last question. Suppose you have the binomial x plus 1 and you want to cube it. How can you expand this? Again, there should be no parentheses in your final answer. And if you get stuck, click over here and we'll figure this out together. Excellent! You fully expanded x plus 1 cubed and found that it equals x cubed plus 3x squared plus 3x plus 1. Multiplying polynomials can be tough work, but if you stick to the table method, you're careful about minus signs, and you combine like terms at the end, you'll get through it. To get started, go ahead and multiply these two binomials, x plus y times x minus y. Be sure to combine all the like terms in your answer, or click down here to review. Nicely done! Multiplying the first terms gives you x squared, the outside terms give you negative xy, the inside terms give you positive xy, and the last terms give you negative y squared. Subtracting xy and adding xy cancel out, so this equals x squared minus y squared. So whenever you have an expression like this, that's the difference between two squares, meaning you're taking one square and subtracting another square, you can always rewrite it as the sum of the bases times the difference between the bases. Just make sure that in the difference you're subtracting the correct base. This is x minus y, not y minus x. So try another example. Can you write 9a squared minus 16b squared as the product of two binomials? Notice that these are both squares here, and if you get stuck, feel free to ask for a hint. Nicely done! 9a squared is the square of 3a, and 16b squared is the square of 4b. So this difference of squares equals the sum, 3a plus 4b, times the difference, 3a minus 4b. Try another example and write x squared minus 25 as the product of two binomials. Precisely, 25 is 5 squared, so this equals x plus 5 times x minus 5. Next, suppose we were to flip this around so that we have 25 minus x squared. Write this as the product of two binomials. Nicely done! This time 25 is the first square and you're subtracting x squared. So this equals 5 plus x times 5 minus x. If you work it out, you'll see that these two expressions are negatives of each other. Okay, now let's see a practical use of the difference of squares. Suppose you're multiplying these two numbers, 53 times 47. Yikes, this is tough to do without a calculator. But if you look carefully, you'll notice that 53 is 50 plus 3, and 47 is 50 minus 3. See if you can use the difference of squares formula to multiply these two numbers without a calculator. Right, so 53 times 47 equals 50 squared minus 3 squared. These numbers are a little easier to compute without a calculator than 53 times 47 was. 50 squared is 2500 and 3 squared is 9. 2500 minus 9 equals 2491. So one application of the difference of squares formula is simplifying some multiplication problems. Just remember that this is the difference of squares we're talking about. If you ever come across the sum of squares, there's no way to write it as the product of two binomials like this. This only works for the difference of squares.